Alright, chapter 3.8 is inverse variation, and it's going to go much quicker than the last chapter. Just as a reminder though, direct variation is y equals k times x, where k is a constant. It's a constant k. Remember, k is, it's just a number, but they call it constant. And this k is also a constant. This is our model for inverse variation. Alright, let me change colors real quick. I don't know which is the best color to go with. Purple. Not orange. Yellow. No. Brown. There's no good colors to go with purple except maybe pink. Alright, in direct variation, we form a line that goes through the origin. Remember that the origin is this point. We usually mark 0, 0. That's the origin. And inverse variation typically makes a curve that looks a little bit like that. And it's a little bit harder to describe, but it has something to do with the fact that we have a fraction here. As the number x gets larger, say we had a fraction 1/2, and we change this denominator, we change it to 1. We change it to 3, and then we change it to 4, and then we change it to 5. Well, 1/2, if this is a whole, then a half is about like that, and a third is a little bit smaller than that, and a fourth would be cutting it in half, and then cutting each one of those in half, so that's going to be down here, 1/4. And 1/5 is even smaller than that. And it makes, as the x moves forward and gets larger, say this is the x. The x is 2, x is 3, x is 4, x is 5, just like we have the x here. As the x gets bigger, the fraction actually gets, the amount gets smaller. And so as the x increases, our y goes down. When we look at a graph like this, as we go this direction, along the graph, our x is getting bigger, our y is getting smaller. It's getting lower and lower and lower and lower. And this is often what happens when we work with fractions. So that's something you just have to see and understand. When we see this format, y equals constant k, some number, over x, as that x gets larger, the whole fraction itself is going to get smaller. And so y is going to get smaller as you move along the number line this direction. So let's look at an example. They just want to say you have to tell whether it shows direct variation, inverse variation, or neither. And they give you 5y equals x, and then you are supposed to solve for y. So you solve for y. So you want to get y by itself. And all you do there to get that to happen is you divide both sides by 5. 5 over 5 is 1, so that just leaves y, 1y, equals x over 5. And this really is the same thing as y equals 1/5 times x, 1/5 x. And so this matches the model y equals kx. Wherever you see a number, you can insert the x or the k, and you can find out, well, that is direct variation. Okay, the next example is, let's change colors. 1/3 y equals 1 over x. Okay, and then to simplify this, we're going to have to get rid of the 1/3 to get y by itself. Again, we're solving for y. So we have to multiply by 3 over 1 and do that on both sides. We multiply by 3 over 1. 3 ones times 1/3 ends up, those cancel through, it becomes 3/3, like that, which becomes just y, because 3/3 is 1. So that leaves y, and then this becomes 1 times 3 is 3. X times 1 is just x, which is 3 over x. And this matches the form when we take our number and we change it for the k. Y equals k over x. This is the indirect. Sorry, not indirect, the inverse inverse variation. Let me make sure we don't get confused there. Okay, so this one is inverse, and this one was direct, and this is our formula because this that looks kind of. Let's take a quick eraser to it. This is supposed to be a 3. So y equals 3 over x, which is the same as y equals k over x, and so it's an inverse variation. It's the one that's going to have this downward curl as the fraction gets bigger. The whole number, as the x gets bigger, the fraction actually gets smaller. And so as we move along that number line, we have this curve happening. So the direct has a straight line that goes through the origin at 0, 0, and the inverse has this downward curve. That's really all you have to know. I told you it was going to be a short video. You were upset at that last 17-minute one, or maybe that was 2 ago, but this is a nice short one.